I am Dr. G. Naresh Kumar. Today I am going to discuss the concept of super mesh analysis for the subject of principles of electrical and electronics engineering. There is a little bit ambiguity among the students among what is the difference between the mesh and the super mesh analysis. So I am going to give a clear idea what is the main difference among those two, and I will discuss with an example so that the analysis can be made very easily. Okay, coming to the super mesh analysis. So what is the main difference between the mesh and super mesh analysis is, in the mesh analysis, there is no current source present in the circuit. There is no current source in the circuit. Whereas in the case of a super mesh, there should be a current source. The current source will be present in the circuit. That is the first and foremost the common difference among the mesh analysis and the super mesh analysis. Okay. Next, so what is the common among these two is, in both the cases we are going to find the loop currents. We are going to find the loop currents. Again, with the help of these loop currents, we are going to find the response in the system. That may be the voltage, current or power across any of the element in the circuit. And again, the one more difference here is we are going to get a combined equation in the case of a super mesh analysis for the loops which are under super mesh. So here there is no need to get any combined equation, just we are going to apply Kirchhoff voltage law and we are going to find the loop equations, and finally we are going to find the loop currents. Okay, so this is having a brief comparison among the mesh analysis and the super mesh analysis. So let us discuss with an example so that it will be having a clarity on the particular topic. So for example, I am going to consider a mesh analysis. I am going to consider a simple circuit and I will differentiate among the mesh and the super mesh analysis. So let us consider a simple circuit. Let us consider a simple circuit of having two loops. So let us see the values for this: 2 ohms, 4 ohms, 6 ohms and say some 5 volts. So this is a circuit. So the given question is, say we have to find the current passing through 4 ohms. So that is the given question. That is the response what we have to find for the given circuit. So we have to solve by using the mesh analysis. Okay. So what is the procedure? The first point is, first we have to identify the number of loops in the circuit. Number of loops in the circuit. So what is a loop? A loop is nothing but a closed path which is going to start and originate at the same point. That is said to be the loop. Okay. Here we can see that this is one loop and this is another loop. So we have totally 2 loops. Okay. So let I1 and I2 be the loop currents. So first we have to identify the number of loops in the circuit. So the number of loops are equal to 2. So I am going to assume 2 loop currents. Let I1, I2 be the loop currents. So how we are going to find the current I here is, first we are going to find the loop currents, and from the loop currents we are going to find the response I for the given circuit. Okay. So after assuming the loop currents, we have to indicate the loop currents in the circuit. So how to indicate the loop currents? So we have 2 sources. So here we can take any one of the source as the reference and we can indicate the loop currents, or based on the 2 sources we can give the current direction based on the respective source. So here I am going to consider any one of the source as the reference and I am going to indicate the loop currents. So I am going to consider the first source which is of 10 volts as the reference. So the current flows from negative to positive in this direction. So the current is going to divide in this direction. So this is in the clockwise direction. This is I1 and this is the loop current I2. Okay. So after indicating the loop currents, the next step is we have to write the loop equations. How to write the loop equations? We are going to apply the Kirchhoff's voltage law. Kirchhoff's voltage law to get the loop equations. So here we have two loops. So we are going to get two equations. So applying the KVL law for the first loop. So what we have to do here is, in the first loop, we have to add all the voltages and equating it to 0 according to Kirchhoff's voltage law. So what I am going to do here is, I am going to add all the voltage across the elements present in the particular loop and equating it to 0. Starting with the source. So this is the voltage source. Then directly I am going to get the value of the voltage, which is minus 10. Next, plus, it is algebraic sum. Next we have the 2 ohm resistor. So how to get the voltage? I into R. 2 into, what is the current passing through this 2 ohm resistor? I1. So 2 into I1 plus. And here we can see that in this 4 ohm resistor, we have both the current I1 as well as the current I2. Both the currents are flowing in the circuit. So we have to consider both the currents. So we have a value of resistor which is 4. So in order to find the current passing through this, here we can see both I1 and I2. Both the currents are flowing in this particular branch. So I have to consider both the currents. So how to write the equation of the voltage for the particular branch? Plus, so with respect to the first current I1, so current is entering in this direction, right? So here we are going to get positive potential. At the end we get negative potential. Whereas coming to I2, current I2 is flowing in this direction. So here I am going to get positive and here I am going to get negative. So if there is any branch, when the current starts passing through that particular branch, at the starting you are going to get highest potential. At the end you are going to get lowest potential. So here we can see that if we consider the potential of this particular branch with respect to I1, here we can see I1 potential is positive for the first loop with respect to second loop. So we are going to get plus 4 into I1 minus I2. I1 minus I2 equal to 0. So totally I have 3 elements in this particular loop. 1, 2 and 3. So we have added all the voltages across that particular loop and equating it to 0. So we get the equation, that is 6I1 minus 4I2 equal to 10. So this is first equation. In the same way, I am going to apply Kirchhoff voltage law for the second loop. Second loop. Okay. So in the second loop, the current is entering in this direction. So starting with the 6 ohm resistor. So what is the current passing to the 6 ohm resistor? I2. So I am going to get the voltage as 6 into I2. Next, in this coming along in this direction, passing of the current for the loop current I2. So here I am going to get the negative potential as the starting. So we get minus 5. So here you have to keep in mind that we have to follow according to direction of the loop current while writing the equation. That is very important. So starting here, it is coming in this direction for the direction of the current 6 into I2. Next, what is starting potential? Minus 5. This is directly the voltage source. So directly I am going to write the voltage. Next, here we can see that with respect to second loop, I2 is positive with respect to I1. So I get 4 into I2 minus I1 equal to 0. So I get the value as minus 4 I1 plus 10 I2 equal to 5. This is second equation. So what I am going to do here is, I am going to solve the two equations. Solve the two equations 1 and 2. Then I am going to get the values of I1 and I2. So once we get the values of I1 and I2, then we have to find the current I how to find the value of current I, which is the given response for the given circuit. So how to find the value of current I is, so here we can see that the loop current I2 is in opposite direction with respect to the current I, whereas I1 is in same direction with respect to the current I, branch current I. So I am going to get I1 is in same direction whereas I2 is in opposite direction. So I1 is positive with respect to I, that is I1 minus I2. Once I know the values of, I will get the values of I1 and I2. The difference between I1 minus I2 will give the branch current I, which is the response for the given circuit. So this is the procedure to solve the response further by using the mesh analysis. Yeah, hope it is clear. So now here we can observe that there is no question of current source in the given circuit. Now we will discuss for the concept of super mesh analysis. So how it is going to be? So as already discussed, in order to have the concept of super mesh analysis, there should be a current source in the given circuit. So let us take an example for that and we will solve that particular problem so that you can have a clear idea on that part. Yes, let us take one example. So let us consider one voltage source and resistors in some series and parallel combination. So this is some 10 volts, 4 ohms, 3 ohms, so it is 6 amperes and say 5 ohms. So this is the given problem. So the given question is find the current passing through say 5 ohms. So this is the given question. Find the current passing through 5 ohm resistor. So how we are going to find here is, the procedure is same, but we have a small change in this case when compared to the mesh analysis. What is that case is, here we can see the current source in between the loops. Okay, whereas in the last example what we have solved by using mesh analysis, there is no question of current source. So you have to keep in mind that if there is a current source in the given circuit, we can say that the particular problem can be solved by using the super mesh analysis. Yeah. Now here the first point is, first we have to identify the number of loops. So the number of loops here are 1, 2 and 3. So the number of loops are 3. So let I1, I2 and I3 be the loop currents. Let I1, I2, I3 be the loop currents, which is same method of the mesh analysis. Here again we have to indicate the loop currents. So taking the first source as the reference, which is the current flowing from negative to positive in this direction. So the current divide here and it is going to divide here. So this is clockwise, respect clockwise, I1, I2 and I3. So I have indicated the loop currents. Next, what is the next step? We have to identify the loops which are under super mesh. We have to identify the loops which are under super mesh. So here we have different cases. What are those cases? Is if there is a current source between any of the two loops, then the particular loops are said to be under super mesh condition. Super mesh condition. When there is a current source between any of the two loops, then the particular loops are said to be under super mesh condition. Here we can see that we have a current source between the loops 2 and 3. So in the super mesh condition we have the loops 2 and 3 loops. So the second and third loops are under super mesh condition. There may be a doubt, like if there is a current source only in one loop, say if we consider the last branch or in the starting branch, if there is a current source, then what is the case? So if there is a current source between any of the two loops or only in one particular loop, then the particular loops are said to be under super mesh condition. This point should be clear. If there is a current source, it is a super mesh case, but where it is locating, that is very important. If there is a current source between any of the two loops, then the particular loops are said to be under super mesh, or if there is a current source only in the particular loop, then only that particular loop will be under super mesh condition. So what is the procedure for this case is, once we indicate the loop currents, we have to identify the loops which are under super mesh. So for the given problem, we can observe that the loops 2 and 3 are in super mesh condition. Why? Because we have a current source between the loops 2 and 3. We have indicated the loops which are under super mesh condition. Next, what we have to write is, we have to write the super mesh equation for that particular loops. As we know that number of loops will be equal to number of loop equations. So since we have 3 loops, we get 3 equations, as we have 3 unknown quantities, right? So here we have to get 3 equations. So the first equation is going to become the super mesh equation. So here we can see 2 and 3 are under super mesh condition. So the super mesh equation is, so here we can see that the direction of the current I3 is in same direction with the 6 ampere source, whereas the I2 is in opposite direction to the 6 ampere source. Here we can see that the loop direction of the current I3 is in same direction with the loop current, whereas I2 is in opposite direction. So I3 is positive with respect to I2. So we get the equation as I3 minus I2 equal to the value of the source, which is 6 amperes. This is first equation. So first we have to write the super mesh equation. Next we have to get the remaining 2 equations. How to get it? Next again we have to check in the given problem if there is any loop which is not having any impact of the current source. Then we have to apply Kirchhoff voltage law for that particular loop, and we have to write the equation. So here 2 and 3 are super mesh. Coming to first loop, there is no impact of the current source in the first loop. So I can apply KVL for the first loop. So applying KVL for first loop, as usual, what we had discussed in the last problem. So we get minus 10 plus 2 into I1 plus 4 into, here we can see that in the branch of 4 ohms, both I1 and I2 are flowing here, the currents. So here we can see the I1 current potential is going to become positive with respect to I2. So we get 4 into I1 minus I2 equal to 0. So finally we get the equation as 6 I1 minus 4 I2 equal to 10. This is second equation. Still I get to get one more equation, that is third equation, to get the loop currents. So how to get the third equation? Here we can see that first we have identified the loops which are under super mesh condition. We have wrote the super mesh equation. Next we have identified the loops which are having not impact on the current source, and we have applied KVL and we have got the equation. And the third equation is the combined equation. The combined equation for the loops which are under super mesh condition. Here we can see that the loops 2 and 3 are under super mesh condition. For the particular loops which are under super mesh, we have to write the combined equation. Combined equation for the loops which are under super mesh, which are 2 and 3. So how to write the combined equation? While writing the combined equation, we have to keep in mind that we have to apply Kirchhoff voltage law. As the name itself indicates, combined equation. So we have to write combinedly the loops 2 and 3 such that we have to eliminate the branch having the current source. Why? Because this was already considered in the first equation. So we have to exclude the branch consisting of current source, and we have to apply KVL and equate it to 0. Okay. So first starting with the second loop. Second loop, here the current is entering at the 3 ohm resistor. So 3 into I2 next in this direction. So we have to exclude this branch consisting of current source. So it is going to be excluded. Next again we have in the second loop 4 ohms. So plus 4 into, so here the potential of I2 is positive with respect to I1, 4 into I2 minus I1. As current I2 is entering in this direction, we get positive and negative. With respect to I1, here we get positive and negative. So I2 is positive with respect to I1 for the second loop. So plus 4 into I2 minus I1. So the second loop is completed. Now coming to third loop. So we have to add the combined equation, right? So we are going to combine this equation. So in the third loop, we have only one branch, which is 5 ohms. So plus 5 into I3. Next, again this source should be excluded as what we have discussed. So which is equal to 0. So totally we have 3 elements in the combined equation of 2 and 3 loops. 1, 2 and 3. So we have got the 3 voltage values and we have equated to 0. So finally we get the equation as minus 4 I1 plus 7 I2 plus 5 I3 equal to 0. So on solving these equations 1, 2 and 3, on solving the equations 1, 2 and 3, we get the values of loop currents I1, I2 and I3. So once we get the loop currents I1, I2 and I3, then we can find the response in the given circuit. So how to find the response in the given circuit? So for the given question is find the current passing through 5 ohms, which is 5 ohm resistor. So here we can see that the current passing through 5 ohms is nothing but the loop current I3. So the current I which is flowing in the 5 ohms is nothing but the loop current I3. Okay. So in the given question, find the voltage across 4 ohm resistor. Find the voltage across 4 ohm resistor. So in order to find the voltage across 4 ohm resistor, first we have to find the current passing through 4 ohm resistor. How to find the current passing through 4 ohm resistor? So here we can see that the current passing through 4 ohms is nothing but difference among I1 and I2. Difference among I1 and I2. With respect to this, we are going to get the value as I1 minus I2, or it can be I2 minus I1. So how to write whether it is I1 minus I2 or I2 minus I1? That depends upon the highest values of the loop currents I1 and I2. So if the I1 value is highest value, we consider it as I1 minus I2, the current is flowing in the particular direction. Or if I2 value is highest value, we get I2 minus I1. So once we get the current passing through 4 ohm resistor, then the voltage across 4 ohm resistor is 4 into that particular current. So this is the procedure how to find the response by using the super mesh analysis. And here I am going to discuss one more case. Here we can see there is a current source only between the loops 2 and 3. There is one more case. If there is a current source in the 1 and 2 loops also, then what is the case? We will have a discussion on that part. If there is a current source between the loops 2 and 3, this is 3 amperes, this is 4 amperes, 1 ohm and this is 6 ohms. Okay. So here the procedure is same. So I am going to have a brief discussion on this part, but because we have had a detailed discussion previously in this models of the problem, so I am going to have a specific description on this part. So here we can see that, so this is the loop current I1, loop current I2 and the loop current I3. So here we can see we have a current source between the loops 1 and 2. So 1 and 2 are in super mesh, and we have a current source between the loops 2 and 3. Again 2 and 3 are in super mesh. So as we have 3 loops, we have to get 3 equations, right? So what about the third equation? So from 1 and 2 in super mesh, we get the equation as I2 is in the same direction whereas I1 is in the opposite direction. We get I2 super mesh equation as I2 minus I1 equal to 3 ampere. This is the first equation. Here we have to keep in mind that we have a 2 ohm resistor here. But even though there is a resistor or not in a particular branch, we have a current source. Right? So then the particular branch will be under super mesh type. If there is resistor of 2 ohms which is connected in series with the current source. And here we can see in the second branch, here there is no resistor connected to that. Whether there is a resistor connected to the particular branch or not, but if there is a current source in a particular loop, then the particular loops are said to be under super mesh condition. So 1 and 2 are in super mesh, we get the equation as I2 minus I1 equal to 3 amperes. Coming to 2 and 3 case. So here I3 is in opposite direction, whereas I2 is in same direction. So we get the equation as I2 minus I3 equal to 4, which is the second equation. What about third equation? And we can observe that all the 3 loops are going to have an impact of the current source. So there is no loop to apply KVL individually. So what about third equation? The third equation is nothing but the combined equation. Combined equation for the loops 1, 2 and 3. Why? Because in the first case we can see 1 and 2 are in super mesh. The second case we can see 2 and 3 are in super mesh. So we can observe directly or indirectly all the 3 loops are going to have impact on the current source. So the loops 1, 2 and 3 are going to be under super mesh. So we are going to have the combined equation for loops 1, 2 and 3 by excluding the branch consisting of current source. That point is very important. So for starting with the first loop, minus 5. Next we have to exclude this branch consisting of current source. Even though there is 2 ohm resistor, we have to exclude the complete branch. So the first loop is completed and come to second loop, plus 6 into I2. So we have to exclude the branch consisting of current source, and again we are going to exclude the branch consisting of current source. Second loop is completed. Now come to third loop. Third loop we have plus 1 into I3, and we have to exclude the branch consisting of current source equal to 0. This is third equation. That is 6I2 plus I3 equal to 5. This is the third equation. Okay. So on solving the equations 1, 2 and 3, we get the loop currents I1, I2 and I3. With the help of these loop currents, we can find the response in the given circuit. That may be the voltage, current or power. This is the second case. The third case is when there is a current source only in the particular loop. Only in the particular loop. Say this is the case. We have a current source only in the particular loop. Then we can say that, so this is the loop current I1, loop current I2 and the loop current I3. So this is some 2 amperes. So directly I can say that we have, as there is a current source only for a third loop. So third loop is under super mesh. Third loop is in super mesh condition. So in the previous case, what we have observed, there is a current source between any of the 2 loops. But in this case, we can observe the current source only in the third loop, only in a particular loop. So we are going to get the equation only for the particular loop, which is nothing but the I3, which is in same direction with respect to the source. So directly we get the equation as I3 equal to 2. This is first equation. As there is a current source only in the particular loop, then we are going to get the super mesh equation only for a particular loop. So as the direction of the loop current I3 is in same with the current source, we get I3 is equal to 2 amperes. Say if the direction of the current source is opposite to the loop current, we get the value as I3 equal to minus 2. As here in this case, the direction of the loop current is same as that of the current source, we get the value as I3 equal to 2. What about the remaining 2 equations? The remaining 2 equations is, here we can see the loop 1 and loop 2 does not have any impact with respect to this current source. So as usual, apply KVL for first loop, we get the equation. Apply KVL for second loop, we get the third equation. On solving the equations 1, 2 and 3, we get the loop currents I1, I2 and I3, and finally we can find the response in the given circuit. Yeah. So in this Class, what we have analyzed is what is the main difference between the mesh and the super mesh analysis, and what are the different possible cases for the super mesh analysis. First one is if there is a current source between any of the two loops, then how to get the response. And if we have multiple current sources in the circuit, then how to find the response. And if we have a current source only in the particular loop, then how to find the response. I hope that it is clear for you what is the main difference among the mesh and the super mesh analysis. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.